Okay, I had a couple of requests for homework question. The first question is number 3. And number 3 says, determine the odds in favor of rolling each of the following sums with a standard pair of dice. Okay, and it's a 12, a 5 or less, a prime number, and a 1. Okay, so let's figure out the probabilities of each of those. Odds in favor of each of those, and then we'll go further from there. The next question, I believe, was question number 9. Question number 9 is right here. And that is, suppose the odds of the Toronto Maple Leafs winning the Stanley Cup are 1 to 5, while the odds of the Montreal Canadiens winning the Stanley Cup are 2 to 13. What are the odds in favor of either Montreal or Toronto winning the Stanley Cup? So we'll do that one next. Okay, 15 was also asked, but I'm going to leave that for now. Okay, so here we go. All right, first things first, we'll do the simple probability calculations. Okay, oh, I should zoom back out again. There we go, it's a little better. All right, so here we go. So the probability, we want to do odds in favor. Hopefully you guys can see that. Odds in favor are going to be the probability of anything happening versus the probability of it not happening, or its complement, or probability of A, semicolon, probability of B. Anyway, so the first one we're going to look at is for 3A is the probability of, the odds in favor of a 12. And that's with 2 dice, okay? So the first thing we're going to do if we're going to do the odds in favor is we want to figure out the probability of a 12, and then the probability of not a 12 we can just do from 1 minus that for the complement. So the probability of a 12, there's only one way to get the 12, a 6 and a 6. So there's one way to get a 12 out of a total of 36, or the first 6 is a 1 out of 6 probability, the second 6 is a 1 out of 6 probability. They both have to occur. 1 out of 6 times 1 out of 6 is 1 out of 36, okay? That's my probability of a 12. My probability of my 12 prime, which of course we also have to know for these formulas, okay, or for the odds, is going to be 1 minus 1 out of 36, or quite simply 35 out of 36. So my odds in favor are going to be P at A, which is 1 out of 36, and then P at A primed, or P at 12, probability of 12, and the probability of 12 primed is going to be 35 out of 36. So the odds in favor is 1 to 35. That means that it's 35 times more likely to not get a 12 than it is to get a 12. Okay, if it's odds in favor, remember, it's happening versus not happening. So it's fairly unlikely that this is going to happen. Okay, it's one time it's going to happen, all right? In comparison to 35 times, it's not going to happen. And that's what we get, a proportional reasoning between those two. For part B, it's the probability of a 5, the odds in favor of a 5 or less. Okay, same idea, same formula. So this is going to be happening, this is going to be not happening. Okay, so the probability of 5 or less is going to be the probability of a 2, probability of a 3, probability of 4, probability of 5. That's 5 or less. Okay, probability of a 2 is 1 out of 36 because you can only get a 1 and a 1 for that one. The probability of a 3 is going to be 2 out of 36, 1 and 2, 2 and 1. Probability of 4, 1 and 3, 3 and 1, 2 and 2, all of those. And the probability of a 5, 2 and 3, 3 and 2, 1 and 4, 4 and 1, 4 out of 36. Add all those guys up, and we get 10 out of 36. I'm not going to reduce it yet. I can reduce it later on, but you know, whatever you want. Sometimes it's a good idea to leave them as it is. That's probability of 5 or less, and of course I need to find that out. That's going to be happening, and the probability of it not going to be happening is going to be 1 minus the probability of 5 or less, which we call the probability of 5 or less primed, okay, the complement. 1 minus 10 out of 36, not too difficult to do. 26 out of 36 is kind of like what's left over from the 36. Okay, then when we go to put it in this particular value here, we get 10 out of 36. That's it happening. And not happening is going to be 26 out of 36. Of course, the denominators reduce. And of course, 10 out of 26 we can also write in lowest terms. That's going to be a 5 to 13 ratio. Okay. For C, we've got a prime number. Now, prime numbers are numbers that only have two factors, 1 in themselves. The number 1 we can't get in this case, but a lot of people confuse 1 as a prime number. 1 is not a prime number. 2 is the very first prime number. 1 is not a prime number because it only has one factor, 1. It can't be 1 in itself because itself is 1. Okay, so my probability of getting a prime number, or the odds in favor of getting a prime number, okay, is going to be it happening versus not happening. Okay, and that's going to go here and here. So as a result, we're going to find the probability of a prime, which is going to be the probability of a, let's put that up a little higher, probability of a 2, plus the probability of a 3, plus the probability of a 5, plus the probability of a 7, plus the probability of a 8, 9, 10, 11. Okay, the rest are composite numbers or not prime numbers. Probability of a 2 is 1 out of 36. Probability of a 3 is going to be 2 out of 36. Probability of a 5 is going to be 4 out of 36. Probability of a 7 is going to be 6 out of 36. Probability of an 11 is going to be 2 out of 36, our 5 and 6 and our 6 and 5. Add them all up and we get 1, 2, 3, 7, 13, 14, 15 out of 36. Okay? So the probability of not prime, which also includes 1. So if you did it separately, you may have gotten the wrong answer that way. Okay, probability of not prime is 1 minus 15 out of 36, which is quite simply 19 out of 36. A little awkward. Okay, so we go 15 out of 36 is the probability of a prime. That's it happening. And then we go 19 out of 36 is the probability of it not happening. And then, of course, we simplify it down to 15 to 19. Now, 19 is a prime number, so it's not going to reduce. 15 to 19. 2, 3, 4, 5. Yep, I think that's correct. Unless I made a boo-boo. Hopefully I didn't make a boo-boo. Okay, that's C. Probability of a 1, or odds in favor of a 1. It's a bit of an unusual circumstance, especially if you write this as a sort of a ratio, because we usually don't have zeros in a ratio. Okay, but the odds in favor of a 1. Okay, it's going to happen versus not happen. Same scenario. Well, the probability of it happening, probability of a 1 is 0 out of 36. Which means the probability of not a 1 primed, is going to be 36 out of 36. So that's going to be a 0 out of 36. That's going to be a 36 out of 36. So it's going to be a 0 to 36, which doesn't seem to make much sense because that's equivalent to 0 to 1. Okay, so it's a bit more unusual of a circumstance. Okay, let's jump right, hopefully that's okay for you guys. Let's jump right forward to question number 9. Question number 9, they told us two things. So this is the, let's see, the odds of Toronto win, okay, are going to be 1 to 5. The odds of Montreal win are going to be 2 to 13. We want to know the probability of Toronto or Montreal winning. So Toronto win or Montreal win. Okay? Now, this is going from odds to probability. Going from odds to probability is not too crazy. So the probability of Toronto winning is going to be, well, this is, remember, this is happening. This is not happening. And then all of this together is the total. So the probability of it happening, that's going to be the top, right? It's going to be number of ways in which there's a Toronto win over the number of ways in total. Well, the number of ways that Toronto can win is 1. The number of ways in total is 1 plus 5. Or 1 out of 6. Kind of scrunched in there. Didn't have much room. Okay, bad planning. Okay, the probability of a Montreal win is going to be, well, again, happening, not happening. Okay, and then the total. Okay, so again, it's going to be the number of ways in which Montreal can win. According to this, there's 2 ways that they can do that. And then in total, what we have is NS Okay, and that's going to be 2 not or winning, and then 13 not winning. So it's going to be 2 plus 13, or 2 out of 15. Okay, so that's the probability of Montreal winning. That's the probability of Toronto winning. So now we got to use a little bit more of our probability chops here. They want the probability of Toronto winning or Montreal winning. So that's going to be the probability of Toronto winning, or means plus the probability of Montreal winning. We do have a bit of an awkward circumstance, God forbid, because we have 1/6 and then we have 2/15. And we could turn them into decimals, but both of them are non-repeating, non-terminating decimals, I think. Yeah. Yep. So as a result of that, then it's probably better we find a common denominator, okay, and find a more accurate representation. So common denominator between 6 and 15 is going to be a 30. So 1/6 is 5/30. 2/15 is 4/30. And so we get 9/30, or if we reduce it all the way to, let me push that up, all the way down, it's going to be 3/10, or a 30% probability. Okay, so hopefully that's fairly straightforward for you. All right, number 15, maybe not worry about that for now. Okay, it's a bit more theoretical. You can think about it a little bit. I've kind of already gone over the notes, so have a look at it in the notes, and we'll see if we can go from there. If you don't know how to do number 15, I don't think that's anything to really worry about too much. Okay, and we'll talk a little bit later. Okay, so good luck on the rest of this.